The phenomenon of continental drift. Why the world looks the way it is. Continental drift is the gradual movement of Earth's continents over geological time, resulting from the motion of tectonic plates on the planet's surface. This theory, originally proposed by German meteorologist Alfred Wegener in 1912, suggested that continents are not stationary but slowly drift across the Earth's surface. The existence of continents is the result of complex geological processes that began billions of years ago as Earth evolved and cooled. Here's how this phenomenon works and its evidence. Key points in the process of continental drift. 1. Plate tectonics. The Earth's lithosphere outer shell is divided into large, rigid plates that float on the semi-fluid asthenosphere beneath. These tectonic plates include both continental and oceanic crust and move due to convection currents in the mantle. 2. Movement of continents. Continents are embedded within these tectonic plates. As the plates move due to mantle convection, circulating heat and material within the Earth, the continents drift along with them. This movement is extremely slow, usually a few centimeters per year, but over millions of years, it leads to significant changes in the positions of continents. 3. Formation and breakup of supercontinents. Continental drift has led to the formation and breakup of several supercontinents throughout Earth's history. For example, around 335 million years ago, most land masses were joined in a single supercontinent known as Pangaea. Over millions of years, Pangaea gradually broke apart, leading to the arrangement of continents we see today. Evidence supporting continental drift. 1. Fossil distribution. Identical fossil species, such as the plant Glossopteris and the reptile Mesosaurus, are found on continents that are now separated by oceans, such as South America, Africa, and Antarctica, suggesting these continents were once connected. 2. Geological formations. Mountain ranges, rock types, and geological structures align across continents that are now separated by vast oceans. For instance, the Appalachian Mountains in North America line up with mountain ranges in Scotland and Scandinavia. 3. Fit of the continents. The coastlines of continents, particularly South America and Africa, appear to fit together like pieces of a jigsaw puzzle, suggesting they were once joined. 4. Paleoclimatic evidence. Evidence of glaciation in regions now near the equator and coal deposits in polar regions suggest that continents were once located in very different positions relative to Earth's climate zones. Significance of continental drift. Continental drift is fundamental to understanding Earth's geological history, including the distribution of continents, the formation of mountain ranges, ocean basins, earthquakes, and volcanoes. It is a central concept in the broader theory of plate tectonics, which explains not only the movement of continents but also the formation and subduction of oceanic crust, the creation of geological features, and the occurrence of natural disasters. The existence of continents is the result of complex geological processes that began billions of years ago as Earth evolved and cooled. Here's a simplified overview of how continents formed and came into existence. 1. Formation of Earth's crust. Early Earth's molten state. About 4.5 billion years ago, Earth was a hot molten mass. Over time, as it began to cool, heavier elements like iron and nickel sank to the center to form the core, while lighter elements like silicon and aluminum rose to the surface. Solidification of the crust. As the outer layer of Earth continued to cool, it began to solidify, forming a primitive crust. Initially, this crust was likely very thin and unstable, continuously breaking apart and reforming due to volcanic activity and impacts from meteorites. 2. Development of protocontinents. Continental and oceanic crust. As the crust cooled, it differentiated into two main types: continental crust, which is thicker and less dense, and oceanic crust, which is thinner and denser. The continental crust formed from lighter elements, such as silicon and aluminum, and was more buoyant, allowing it to float higher on the semi-fluid mantle. Tectonic activity and early crustal blocks. Convection currents in the mantle caused the Earth's crust to break into tectonic plates. Over millions of years, these plates moved and collided, creating crustal fragments or protocontinents. Through repeated cycles of volcanic activity, subduction, and collisions, these fragments grew in size and stability, forming the foundations of the first continents. 3. Growth of continents through accretion and collision. Accretion of material. Protocontinents grew larger by accreting, or adding, material from volcanic activity and from smaller land masses that collided and merged with them. This process continues today, with tectonic plates carrying islands and microcontinents that collide with larger landmasses, adding to continental mass. Mountain building and crustal thickening. The collision of tectonic plates also leads to the formation of mountains and thickening of the continental crust, which stabilizes the continental landmass. 4. Formation and breakup of supercontinents. Supercontinent cycles. Over billions of years, continents have repeatedly joined to form supercontinents, like Pangaea, and then broken apart. This supercontinent cycle, driven by plate tectonics, has occurred multiple times throughout Earth's history. Each cycle reshapes the continents, creating new coastlines, mountain ranges, and ecosystems. Modern continents. The current arrangement of continents is the result of the breakup of the most recent supercontinent, Pangaea, which began around 175 million years ago. Through processes of seafloor spreading and continental drift, the continents moved to their current locations. 5. Role of erosion and weathering. Surface shaping. Over millions of years, processes like erosion and weathering have shaped and modified the surfaces of continents, creating varied landscapes from mountains to plains and valleys. Summary. Continents form through a combination of cooling, tectonic plate movement, volcanic activity, and gradual growth from smaller landmasses. Plate tectonics continues to drive the slow, dynamic movement of continents, creating and reshaping Earth's landmasses over geological time. The phenomenon of continental drift,